Hello everyone. Today we will measure the frequency response of RC filter. For doing so, I will build RC filter with 10 kilo ohm resistor and 0.01 microfarad capacitor. As you can see here is my 10 kilo ohm resistor, and here is 0.01 microfarad, which is 10 nanofarad capacitor. We put there in series, and then I supply the AC signal with function generator, and I measure the peak-to-peak voltage drop across the capacitor with multimeter. Here's the function generator that is connected. I connect it to channel 1 of function generator, and here is my multimeter. I use the voltmeter channel of my multimeter. Next step is building VI with Labview, so it automates the frequency response measure based on different frequency provided by function generator. It measures the In this step, we building the VI of this experiment. In first step, we will build the front panel of our code of our VI. As you know, we dedicate the front panel for representing our inputs and outputs. As you get used to it until now from previous experiments, the most familiar part of front panel is XY graph. So first of all, we add XY graph to our front panel, and next step, we need two fields for our power supply and our multimeter, Rigel power supply and Rigel multimeter. So we go to VI source and Visa resources field and add two field. Each field we will dedicate it for specific input. So first field is for power supply, and second field will be dedicated for multimeter. So then you can have two drop down lists. For one of them is for, you have DP, another one we have DM, which represent the multimeter. So now after these, we can go and build our back panel for this VI. In back panel, the logic of our program, as you know, it will be in back panel. So from lab manual, you know that we want to use the first channel of function generator, and first we want to do the operation or the function that we want to use from multimeter is measuring the peak-to-peak voltage, which is come as operation number 1 in the driver of, this is the default of our driver for a Rigel device multimeter. So then we add two numbers just for representing which channel and which function of multimeter we want to use. Then after that, we want to add our device or initiate our device. So the power supply we should go to instrument, IO instruments, as you can see here, and go to drivers and initiate the power supply. Then we should go and initiate our multimeter, as you can see in this figure, and as we did it in previous experiment for measuring VI characteristic of diode. So then you want to define the structure of your program, of your code. So first of all, you need to increase the frequency that it comes from function generator, and in each iteration increase it by say 10 kilohertz, depends on the structure of your program or what you want to measure. Then inside the for loop we want to use again frame, the concept of frame in Labview. So we go to programming and we go and frame, a simple frame. And first frame we want to first of all set the function generator in the specific frequency. Then for the frame after it, at that frame we want to measure the peak-to-peak voltage drop across the capacitor. And then at the third frame we want to plot the result and see the frequency response of this simple RC low pass filter. Now go to build our first frame. So in first frame we need to set the frequency of the function generator. Let's say the sinusoid wave, we pick the sinusoid wave for function generator. So we need to set the step size of increasing the frequency and the frequency that we need to start our sweeping from. So as you can see here, we connect in each iteration the I to the input of multiplication. Then and for second input of multiplication block we define the frequency that we want to start from. Let's say I start from 10 kilohertz, and in each iteration I increase my frequency, the frequency of sinusoid, start sweeping from 0. So actually we start from DC, then so we start from frequency of 0, then increase in each iteration we increase 10 kilohertz, the frequency of our sinusoid. And as you can see here, we need to pass this value, the value of frequency, to our function generator, and we set the function to be sinusoid 1. As you can see here, the number 2 at the top, this frame, it indicates that we use the sinusoid waveform. So after this we pass this and we set the active channel. Actually we active the channel, which is, as I explained before, we use channel 1. We use channel 1 and function generator to set it. Now at this step we add the timer, so you're waiting for a few seconds until the circuit go to steady state, which is, in this case we put 5 seconds, which is more than enough for circuit to go to steady state. And then we pass the value of frequency as X to the XY graph. In next frame it's very intuitive, we just set the multimeter to measure the peak to peak. And so in second frame it's just a matter of connecting the multimeter to this frame and make it set it to measure the voltage, peak-to-peak voltage drop across the capacitor at that specific frequency. And this, as you can see, that's in for loop, it's gonna increase the frequency each time in 10 kilohertz up to for 20 times, which means we end up with 200 kilohertz. and we're going to measure the frequency response of this circuit from DC up to 200 kilohertz. And we pass the voltage that is measured from frequency and the voltage drop across the capacitor to XY graph. So XY graph going to plot the result for us, and we can see the result. So here is the XY graph. Now we are done with our back panel, our code, and we are done with our VI, so we can run the code and we see the result and how this whole automated process will measure for us the frequency response of low pass RC filter. The function generator is turned on. Start from 1 kilohertz. From 0 kilohertz, measure the voltage, and let's start to plot the frequency response of this RC circuit for different frequencies. As you can see, the frequency is increased 10 kilohertz in each iteration, and there is the voltage dropped across the capacitor, peak-to-peak voltage. And this is the peak-to-peak voltage. It goes up to 100, and we should expect some graph here. As you can see, here is our frequency response of our RC circuit.